Hey everyone, this is Chauke again, facilitator of Building and Structural Construction N6 at Majiwa TVET College. We're still going to be using J. Bischoff as our reference book. So this should be our last video. Continues our problem dealing with topic moment of inertia. Okay, so this is part number 1C of our video then. So we did number 1, position of a centroid, moment of inertia, number 2, number 3, maximum moment of resistance, we did that one, number 4, maximum uniformly distributed load, we did that one. So now we are going to do number 5 and number 6. So number 5 is maximum imposed uniformly distributed load. So one to determine the imposed load. Okay, remember this one was the total load, the overall load, but now how much load can we impose on our beam? Okay, and then number 6, that will be a position and the magnitude of the maximum shear stress. Okay, so now let's go to number 5. Number 5, the maximum imposed uniformly distributed load. Now how do you go about it? You'll remember you start by calculating the dead load of your compound beam. All right, so remember we've got I section, we also have a channel. So we need to locate the masses of both. Let's go and look at our channel first. What is the mass of our channel here? It is what? It is 22 kilogram per meter, right? 22 kilogram per meter. And then for our I section, let's see here, 22 kilogram per meter, remember that. And then our section, for our I section, which is this one here, the mass is 25,3. Okay, right. So now what you see here, it is the mass 23,3 for our I section, 22, which is for our channel, and then you add the 2 and then you multiply by 9,81. all right, and then that will give you newtons per meter, and then you divide that value by 1,000 to get kilonewtons per meter. So the dead load or the self weight of your compound beam will be 0,46. Okay, then now we want the imposed load. So the total load is equals to the dead load plus imposed load. So the dead load is the self weight of that steel. All right, the self weight of that steel, it is the dead load. And then the imposed load is the one that you're gonna be imposed. Can be your brickwork on top of that beam, because it's the maximum imposed distributed load. So your imposed load is gonna be UDL. So you just take the total load that we have calculated here, which is 11,82, and then you subtract the dead load, the self weight of the beam, which is 0,46, and then you get the imposed load, meaning that the beam or our compound beam can carry up to 11.36 kilonewtons per meter. All right, nothing more than this. Okay, it can carry up to 11.36 kilonewtons per meter of the load. Okay, so if you want to load your beam, the weight, it should not exceed this value. Okay, so that's what we were looking for all along. Okay, let's say for example we've got a plate. All right, because I want to do another example on a plate. Let's say we've got a plate. Remember these two values, we got them from a steel table, right? From the dimensions. All right, these masses, but you cannot get a mass of the steel plate from the steel table. So how do you go about it? You will have to listen carefully. You will have to determine the mass using the formula density is equal to mass over volume. Okay, so meaning that the mass is equal to what? Volume multiplied by the density. You'll be given the density of the steel, normally is 7850. Okay, you'll be given the density of the steel there. So now the volume, how do you calculate the volume? So that I don't explain a whole lot of a long thing, don't use the volume, use the area. Why? Because remember, volume is length multiplied by breadth multiplied by the height. All right, so you are only interested on the length and the breadth of the steel. I mean the breadth and the height or the thickness of this the steel. You don't know what about the length, which is the length, which is the span of the beam. Okay, because what's going to happen is if you multiply it by the span, you're still gonna divide it later on to get to get that kilonewtons per meter. So use the area, which is what, which is the breadth and the width, or the height of the plate and the thickness of the plate only. Don't worry about the span. So it will be area multiplied by the density of the steel, which is normally 58, around 5850, and 9,81 to get your weight now, and then you divide it by this 1000, all right, to get kilonewtons. So if you're given a plate that, so normally they would like to trick you using a plate, all right. So to get the weight of the plate, you say what? Area times the density times the gravity, all right, and then you get the weight, and then divide it by 1000 to get kilonewtons per meter. So that's about it with a plate. All right, so now we have got the imposed load, which is 11.36 kilonewtons per meter. All right, so the last section here now, we want to deal with the position and the maximum shear stress. All right, the position and the magnitude of maximum shear stress. So how do you go about that one? Let's deal with the position. The position of the maximum shear stress will be at the supports. How so? It is because the load, okay, do it traditionally by calculating the reactions and the supports, all right, or yeah, the reaction, and they determine the shear forces at each and every point. You'll realize that the maximum shear force will be at the support, right? And where there is a maximum shear force, that's where you're gonna have what? Maximum shear stress. So the position of your maximum shear stress will be at the reactions or at the supports. All right. So that tells you or guides you on what you're gonna be doing here when you calculate it. Now that we know this is gonna be at the supports, how do you calculate it? You just calculate the reactions. Also, you take the total weight and divide it by 2. Because our weight is a UDL, we multiply it by what? A span, to get rid of that per meter. So pay attention. The shear load, which is the maximum shear force, is the total what? Load over 2. Y over 2 to get this is more like the reaction at the support. You get the total load divided by 2, and then it's gonna be a reaction on the left and a reaction on the right hand side. You see, but we multiply it by what? By span. Why? Because we want to get rid of that. Because this one, it's a UDL. If it was not a UDL, we wouldn't bother by multiplying the weight by the span. All right. So the total load divided by 2. So total load, as we said, it's gonna be 11.36. Okay. No, sorry, it's 11.82. The total weight. All right. This one. All right, multiplied by the span to get rid of per meter over 2, and then we get 31.32 kilonewtons now. Okay, so this is the max. So this is your reaction. on the left, and then which is equals to the direction on the right hand side. So the shear force, or the maximum shear force, is going to be 31.32 kilonewtons. All right, then now to calculate the shear stress, is force over area. All right, and then which force? The maximum shear force, the maximum shear load that we have calculated here. All right, 31.32 all over the area. But what area? You have to remember that the area that's going to experience stress is going to be this column here. Okay, the flange, the web rather, plus the thickness of the flange and the thickness of the flange. You'll remember that from N5 is from here to here, this column. All right, so it's going to be this height, total height of the what? Total height of the I section, which is 203.2, right? Multiplied by the thickness of this. All right, so this is going to be T1 of the I section. All right, and then how do you go there? How do you get the T1? Let's go to that I section there. Let's go to the I section here. Here's the I section. All right, the total height is going to be 203.2, and T1 is the thickness of the web. All right, and the T1 is what? Is 5.8. Okay, it's 5.8. So that would be your area. All right, that will be your area. So your area will be this 203.2 multiplied by 5.8. all right, so the answer that you're going to get is going to be 26.57 Newton per millimeter squared, which is the same as MPa. All right, guys, so this is about it. I hope you will learn something from this video. Any question, drop a comment. You should be able to get hold of me. Thank you very much.